A cylinder. A cylinder is a surface that is traced out by translating a plane curve called the generating curve parallel to a given line. We've already been graphing cylinders. Except the cylinders we've been graphing have been planes. Earlier when we had I had a couple of them. We had these two. When we had x equals 4, we graphed in the xy plane the vertical line x equals 4, and then we thought of translating it up and down to get this plane in red here. Or in this one, we graphed this generating line, x plus y equals 2, translating it vertically corresponding to the variable that's missing, the axis corresponding to the variable that's missing in the equation. We translated it vertically to create that plane. Well, that's also called a cylinder, believe it or not. When you create a surface by translating a one-dimensional curve along a straight line, you create a surface that's called a cylinder. Sketch y equals the sine of x. You think, great, I've done that a million times. But wait, this is in R3, right? So how do we want to graph this thing? Well, let me show you. Let me draw in my coordinate axes. And then I think I'll go back to calling this guy this guy here the positive x-axis, and this guy the positive y-axis. And then let's just draw the generating curve in the xy plane, the typical sine wave. So how do you draw the typical sine wave? Well, you know that it starts, I'm just going to draw one period of it, actually. So you know that it goes through 0, 0. So like you're looking down on it, right? You guys have all drawn sine waves a million times. One period of the sine wave looks like this, right? But I'm going to try to give it a little bit of perspective here, and then I'll extend it. So if you think about what you did in trig or pre-calc, you kind of split it up one single period into fourths, right? And so this, it's this value here is 2 pi, and this is pi over 2. It reaches the peak at pi over 2. It reaches its minimum value of 1, well, maximum of 1, minimum of negative 1 at 3 pi over 2. So you've all drawn that graph before, right? Hopefully neater than what I just did. So now I'm going to try to draw that and giving it the kind of the perspective from above in this R3 that I've created here. There's your z-axis. So let's see if I can do that. So if I go, let's see, out here, maybe a little, actually that was fine. And then I'm going to split it up into fourths, just like I did over there. Okay. So I know it's going to reach its maximum value at this hash mark, which corresponds to this hash mark, right? So the maximum value, of course, is 1. I'll make that 1. And so that's 1 on the y-axis. And then, of course, this is negative 1 on the y-axis, right? So let me plot a few points here, trying to give it some perspective at that point. That's going to correspond with that point, right? And then that point corresponds with that point. And then wherever these guys meet at a corner, that's going to correspond with that point. And then this point right here corresponds with this point right here. And so I'll attempt to draw it. Sometimes I do a good job, and sometimes not so good. Okay? But that's just the generating curve. So what do we have to do? To keep it simple, I'm just going to translate the generating curve upward. I'm not going to try and go down. But it goes up forever and it goes down forever. So what do? Well, I decide how far I want to translate it up, and I stick with that value. So you could get a ruler out, and let's say you want to translate it upwards Let me use the same. You know what? Let me use a different color here. That might actually be helpful. So I'll use blue. So I'll translate this point upwards. Try to make that look vertical. That distance. Now, if you have a ruler, you can figure out how long that is and make copies of that vertical line. I can do that by just hitting Control C. So I need 1, 2, 3, 4 more copies of that. And of course, doing it manually, you'll just use a ruler, get the distance, and then from say this point right here, you'll go up that distance and then put a dot and connect the dots, right? So it's like I'm translating this point up to here, this point up to here. And so you could do that with a ruler on just pencil and paper easily enough. This point, but make sure they're all the same distance, right? Okay, so it's like you've translated this point up, this point, this point, this point, and then you're just going to try to draw the same exact curve again, which isn't always easy. And then if you want, you could shade it, or you could just put in more copies of that vertical line. So maybe a copy here, and a copy here. And it gives it some semblance of 3 dimensions, I think.